Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala if you prefer. In this video, we'll be taking a look at the Wagon Wheel Moon explained in Stellarium. We will start off in Stellarium. It is a free site. You can punch into just about any search engine and it should pop up. You can click right into it and take off and get going. We are going to start by clicking on this little box in the bottom left hand corner, and it allows you to move your location. Now we have gone to 90 degrees north. That's where we're going to start. We will lock onto the moon. We're going to set our date to 2/5/22. This will be the day Elsie King and I will be taking our measurements, as that will be the day the moon is passing over the equator. We will lock onto the moon. We're going to zoom in here. And we'll move it around a little bit. We're trying to find south from our position. So we get it kind of close. I don't think I had realized that you can lower or remove that atmosphere in there, or the ground part. As we zoom in, you'll see here we're going to get it to line up so we're looking 180 degrees south, which is really in every direction. But as you can see, as I'm going through the day here, the black dot on the moon to the right, or at the 90-degree point, isn't moving at all. There is no wagon wheeling taking place. So according to Stellarium, in our globe model, from 90 degrees north, we would see little to no movement at 90 degrees north in our moon. This is exactly what I hypothesized would happen. Now I'll show you what that means over our flat plane. As you can see, the red dot is to the left and the blue dot is to the right. And since we are at the pole, it doesn't matter which way we look down our point of view, the red dot will always be to the left and the blue dot will always be to the right. Almost making a perfect T when we look at it. Never changing their angles. They're always on that red line, the blue and the red dot. So, flat Earth, globe Earth, exact same from the North Pole. Now we'll go to Spartanburg, South Carolina, which is just down the road and where I'll be taking my measurements from on the 5th. And we'll use this location. It is about 34.949 degrees north, so 35 degrees north roughly. We will line it up with perfect south. The one thing about Stellarium that's kind of weird is you can see through the ground. I'm looking at 3 a.m. I'm going to have to go to the afternoon hours here. So we'll fast forward it. And there is our meridian, our north-south line. Stellarium is really neat. The ability to line things up perfectly. I really like this for time calculations. It has this guy down pretty good. So here we line it up. We're 180 degrees south. We'll pause it so it stops moving. Get it lined back up perfect to the second. And there we go. Now as you can see, just like in the north, from 90 degrees north, our black dot is to the right at the 90-degree mark right there. See that? But now watch what happens as we change the time. And since our perspective is from a different point of view, that dot moves. I was trying to find the azimuthal lines to tell me what degree I was looking at here. I'll find it here in just 1 second. There it is, the azimuthal grid. And that pretty much will tell you what degree you're looking at geographically from your perspective, your point on the plane. So there we go, we're at our meridian mark passing south. And as we go forward 3 hours, it rotates there's forward. We went backwards 3 hours. There was forward 3 hours, and it's rotating clockwise. So as it's passing meridian, the black dot will always be to the right. And from the north, we will see the moon rotate clockwise. Except from the North Pole. Now here's what that looks like. Now we're on that 0 degree line there. And right at that arrow next to the ruler, that's our point of view. And we're looking at the sun, and as you can see, the dots are no longer perpendicular to our ruler. They don't make a perfect T, it's more of a slanted T. The red dot is up above, and the blue dot is now below where we cross the center of that sun. But yet again, once it's on our meridian, the black dot, the blue dot was to the left, or to the right, and the red dot was to the left, just like from the north. And we line it up this way, and as you can see, now our red dot is below the halfway mark, and the blue dot, which is kind of hidden by our number 10 there, I'll try and move it, but our number 10 there is above our perpendicular lines coming off the edge of the ruler. Now we will go to the South Pole. And as I predicted from the South Pole, we should see the exact opposite from the north. We will see it move from right to left and rotate counterclockwise. Well, really, we won't see it rotate at all from the South Pole. But as you get in away from the pole, that's when you get your counterclockwise rotation. So as you can see, we're going to line it up here. It really doesn't matter since we're on the South Pole. And it looks like we're getting ready to go through a new moon right here. I was just kind of looking to see what the light did there and what direction it's coming and going from. But as you can see, as I'm moving through the days here, the actual rotation of the moon, the counter or the clockwise rotation, doesn't take place. It may move slightly askew. It seems to happen right when the shadow is coming, so I think it's more of a perspective thing with the shadow, making it appear to look like it's rotating. But as you can see, our spot now is to the left. It's at the 270 spot, exactly opposite of what we saw in the north. Remember, it was to the right in the north. Now, in the south, we're looking at it and our spot is to the left. But it's still leading the moon. It's always, moon moving east to west. That spot should always be in the western part of the moon when you're lined up with your meridian. And here it is looking from the south, though, on a flat earth, and it is not anywhere near what we see from the north. It's almost the exact opposite, almost. Now here, when it lines up with the meridian, the north-south line, perfect. Blue on the left now, red on the right, so we get our opposite, just like in Stellarium. But as we go back out here to this mark, a South Pole mark on this longitude line, we get totally different than what we saw in Stellarium. Again, the exact opposite almost from what we saw when we took the measurement 3 hours before. Now what's really interesting is on the globe model, 33 south, which is Sydney, Australia here, is where we'll take our next measurement from, is very similar to 35 north, almost identical. And we'll show you that when we bring it up on the flat Earth map, it will be night and day difference. So this really will be a definitive test in my eyes to tell what we are seeing up there in the sky. I mean, the sky is such a mystery already. This would just throw a big old monkey wrench, at least the way I look at the sky and how perspective works. So yeah, I'm very interested to see what happens here. So now we're down in Sydney, we're going to find our moon, and we're going to want to face north. So we're going to line it up. We've clicked on the moon. We're zooming in. Just like the South Pole, our spot is to the left. Right about the 270 degree mark. We will get it all nice and lined up again. Now as you see, as I jump the hours forward and backward here, 3 hours before and 3 hours after the meridian, you're going to see that it rotates about the 90 that it did from 35 north. It'll be a little bit different because they're not the exact same north-south latitudes. But you'll see as soon as I go back to the flat Earth map how much different it could possibly look. Now again, we could get this in the sky and it's just going to make it that much more of a puzzle, the sky. So I'm really just excited to find out what it is. I mean, I'm not going to change my mind about this not being a spherical ball Earth because of this. There's too much evidence. And here we go from 37 south. We look, and this is real interesting because it almost lines up with the dots. Almost as if we should see about 180 degree difference. Again, blue dot on the left, red dot on the right. Exactly what we would see from the South Pole on a globe. Or on the FE if that was your South Pole mark, you know. And then we go back out here and it's just about 180 degrees. Those lines, those dots line right back up. So it should be a very definitive test, what we're going to get. And I'm real excited to share it with y'all. Good times for all here. Sign out. As always, thanks for watching.